To solve this interesting equation, we are going to first of all convert the natural logarithm to an indicial form. And how do we do that? Because the natural logarithm has a base of e, we're going to convert it to the power and say e to the power of x cubed, and that equals x to the power of 9. And from here, our next aim is to make these two powers exactly the same. And to achieve that, what we are going to be doing is that we'll be dividing the powers of both sides by 3. So we have e to the power of x cubed divided by 3, and that equals x to the power of 9 divided by 3. And when we divide e to the power of x cubed by 3, it gives us e to the power of x cubed all over 3. And this here gives us x to the power of 3. Now we can see that the powers are now exactly the same. From here now, what are we going to do? We're going to try to bring these two terms together. And how do we achieve that? We divide both sides by e to the power of x cubed all over 3. And then when we divide both sides by this, we are going to achieve the equation to be of this form. We'll have 1 at the right hand side, and then we have x cubed divided by e to the power of x cubed all over 3. And then this, after being simplified, will give us 1 equals x cubed. We're going to apply the law of indices and have times e to the power of minus x cubed all over 3. Now, after doing that, our next aim is we want this power and this coefficient to be exactly the same. And how do we achieve that? We are going to be dividing both sides by minus 3. So we have 1 divided by minus 3, and that equals x cubed times e to the power of minus x cubed all over 3 divided by minus 3. And then after dividing this, we are going to have our equation to be in this exact form. At the left hand side, we will have minus 1 all over 3, and that equals, at the right hand side, we will have minus x cubed all over 3 times e to the power of minus x cubed all over 3. And now that we have successfully made the coefficient and the power to look exactly the same, we are going to be applying the Lambert W function to get our final answer. So we're going to be taking the W function of the equation. We have W function of minus 1 over 3 equals minus x cubed all over 3 times e to the power of minus x cubed all over 3. And due to the property of the Lambert W function, we know that when you take the omega function of an equation that has a form of m e to the power of m equals a constant or a number, then the value of m will give us the W function of that constant. But in our case, the m stands for minus x cubed over 3 and the constant stands for minus 1 all over 3. Therefore, we'll be applying this property to find our final answer. And now to get the value of x, we're going to say the W function of minus 1 all over 3 equals minus x cubed all over 3. And from here on, we are going to be solving for the value of x using the normal algebraic methods. And we start doing this by cross multiplying. So we're going to have minus x cubed to be equal 3 times the W function of minus 1 all over 3. And also, we multiply both sides by minus 1 so as to swap the sign. And then we have x cubed to be equal minus 3 times the W function of minus 1 all over 3. And then finally, to find the value of x, we are going to be taking the cube root of both sides. So we have x to be equal cube root of minus 3 times W function of minus 1 all over 3. But here now, we are going to be having two different values of x. So we're going to say this is our x1. We are also going to have a second value of x, which will be x2. And the reason why I said that is because as a property of the Lambert W function, whenever we are evaluating the Lambert W function of a constant that is negative, there is a probability that we are going to have two solutions. So when you take the W function of a number, it's either we have two solutions or no solution at all. And because minus 1 over 3 is within the domain of the W function, it means we are going to be having two solutions. And the first solution is going to be gotten using the first principal branch of the W function. And then the second solution is going to be evaluated using the lower branch. That's the second branch of the W function. That's minus 1. Then minus 1 all over 3. We are going to be evaluating these two using the Wolfram alpha. So now when we input this into the Wolfram alpha, we are going to get the W function of minus 1 over 3 using the upper branch. That's approximately equal minus 0.61906. And then for the x2, when we use the Wolfram alpha, that's the lower branch, we're going to get the W function of minus 1 over 3 to give us minus 1.5121. And then finally, when we evaluate this using our calculator, we are going to get that x1 will be approximately equal 1.2292, and then x2 will be approximately equal 1.6554. And these are the two valid solutions to our equation. And guys, if you learned something from this video, don't forget to subscribe for more, and do have a good day.